The ancestral Pacific Ocean, the North American continent lay to the east, and we know from plate tectonic reconstructions that around 470 million years ago, when the sediments that gave rise to these rocks were laid down, North America straddled the equator back then. And it was also roughly rotated about 45 degrees from clockwise from how it is today. So that's the sort of environment that these rocks accumulated in. And then, so you would have had, silts and clays laid down, and that ultimately, when it gets deeply buried and shot through, with hot fluids and squeezed, and it transforms into this rock, this sort of scaly rock known as schist. And that's what the brown stuff is schist.
It's all metamorphic.
It's all metamorphic, yeah. And then because all of this change and transformation is happening at great depth, probably several miles beneath the ground surface, the rock is so hot and it's under such high pressure that even as it's undergoing change, it's twisting and folding, and it's being just...
Is that an example of it right there?
Yeah, it's being just stirred up like taffy. It's tempting to look at the schist. And if you look at it, you can probably see layers, and the layers are sort of twisted. It's tempting to think that the layers are similar to the layers in sedimentary rock. But this is actually more of a stress-induced, a pressure-induced layering called foliation. So if you have a rock and you squeeze it this direction under high pressures and temperatures, if originally the minerals are maybe randomly oriented in the rock, can you appreciate that if you squeeze it like this, they'll sort of come into a more or less subparallel alignment, kind of perpendicular to the direction that they're being squeezed. So that's what's creating the kind of the stratification or the layering seen in this rock. It's not the same sort of layering that we see in sedimentary rock. This is more of a stress-induced layering called foliation.
It's a vehicle coming.